Good day. Welcome to another class today from Jeho Ashar Energy. Today we'll be discussing a very important topic that helps everyone into solar energy systems and other communication systems. And the topic is on your CAN /RS485 communication cables. CAN RS485 communication cable. You can see this is one of the cable I'm holding in my hands. So this CAN RS485 communication cable, what does it do? In a simple term, this cable helps communication between devices. It helps communication between devices. We are into solar energy systems, so we'll be focusing on equipments that are used in solar energy system. So let's say, for example, your inverter and your lithium battery. This cable helps the both to communicate. Now there is the power side of your inverter and lithium battery, which is that red and black cable you have, the positive and negative. This only just helps in transmitting power. But the communication between the battery and the inverter, the inverter wants to know the battery temperature. The inverter wants to know the state of charge, the state of discharge, the capacity, the SOC. That is a state of charge, yes, that's what I've said, percentage, discharge, the what other information, the energy left in the battery. So a lot of those communications can only be detected not through that positive and negative cable that you connect from your inverter to your battery, but through what? This CAN RS485 communication cable. Also between your MPPT solar charge controller and your inverter, there's this inverter brand Vitron. They lose a lot of this cable because there are a lot of devices connected to the inverters that there's a need for communication in between those devices. So this CAN RS485 communication cable come into play. It helps your inverter to communicate with your battery. And the benefit of that is for the safety of your battery, lifespan, longevity of your battery. Yes, you could install a solar energy or an inverter system with a lithium batteries. So we're focusing on lithium batteries, and we're focusing more on lithium batteries because that's the latest technology we are handling presently. Back then you have even some people still use it, your tubular batteries, your dry cells. Lead acid battery, we have the wet cell, we have the dry cell. All those don't require any communication because they don't have an internally built battery management system. But for lithium batteries, they have internally built battery management system for the cells. So if, for example, you have lithium batteries, these are the cells inside. Positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. So say, for example, these are connected together. Now, this guy goes into a flat, there's a panel inside, the BMS. This is a panel inside of it. So this BMS is called your battery management system. This is your cell, right? But there's a board or a controller inside or a manager inside that manages what happens in these cells. For example, these cells might be having a voltage of 3 volts. This might be having 2.9. This might be having 2. This might be having 3.1, 3.0. all these are not balanced. So what can help them to be balanced? What can detect the information of each of these cells? What can detect that each of these cells is being overcharged? What can detect the temperature of each of these cells? What can detect what is happening to each of the cells, right? That's what the battery management system does. Inside of it has a lot of programs that carry out the function we have just listed out. So lithium-ion battery has a battery management system. So we'll be discussing the importance of this. Most times people install inverters, and when they've installed their inverter, the inverter have various battery settings you could pick, or mode. They have various modes. You have the flooded, you have the gel, you have the AGM, you have the lithium, and you have your custom. So most inverters hybrid inverter come with this selection, and when you have your lithium battery by the side. So for example, if you are using a wet cell, dry and lead acid battery wet cell that is flooded, you are going to your battery mode, you are going to your battery settings. Under your battery settings, you can select flooded. If it's gel, you select gel. If it's AGM, you select it. And once you select it, the inverters have a default setting from probably various analyses they've done. They now pick an average of, okay, we select AGM. Okay, this is the charging voltage of AGM battery. This is the discharge cutoff voltage. These are the parameters that should be applied to AGM. But of course, not all AGM have the same parameters. Gel battery, flooded, lithium, and custom. So for lithium, once you select lithium battery, and also let me draw us back to the gel also. Some inverters would ask you for the manufacturer, that is a brand name. So if you selected AGM, what is the brand of your AGM battery? Is it Quanta? Is it name the brands you mean? So the inverter manufacturer will have those brands in their program inside the inverter, so that once you select it, it automatically pick up the specifications on that battery by the manufacturer of that battery. For example, if you pick, say, Quanta or Mombat, once you pick it on the inverter, it goes to get, and you put the capacity, let's say 200 AH, 12 volts. Now, it automatically pick what is stored in its storage, like what relates to this battery. It picks the physical specification you are seeing on the battery inside the inverter and merge it to the charging parameters, so it's able to work with what the battery has been designed to accommodate or accept. The same applies to Quanta. So today we'll be focusing on lithium. Now the last one is the custom. Custom setting is you setting those parameters yourself. You've gotten a battery, a lithium battery for example, and you can't pick the communication protocol on the inverter you got, because most inverter manufacturers have a protocol that helps this man communicate between the inverter and the battery. So if you can't pick that protocol, you select lithium, you probably try some numbers of protocols, 1, 2, 3, 40, the various numbers, and you can't pick it. The only option you have left is to go to custom. And what that custom does is you setting the charging voltage, the low cutoff disconnect voltage, the floats, and the charging currents, and other information. So once you pick that, it means that what you are doing is this. You only have an inverter machine with a lithium ion battery with only the power cables, positive and negative. You don't have your RS485 or CAN communication. And this battery has a BMS. This is a battery. It has a BMS. So since you don't have your communication cable, this cable between the inverter and the battery, all you just did is to do a custom setting, or we call it a user setting. You input what is the voltage, the charging voltage, the cutoff voltage, you input the currents, charging currents, CC, you input other informations you need to put, floats, the float charge, you input them. But now, it means that this inverter is left to work with this information you have inputted into this. But this is a drawback. Without this BMS or this RS CAN 485 communication cable between your inverter and battery, your battery or your inverter can't get the information of the battery temperature. Most lithium battery, they will tell you let the temperature be at 25 degrees. But without that communication cable, the inverter can't know that temperature. So why do you need to know the temperature? Because when a battery is being charged, there is heat produced, right? So when you keep on putting more current into the battery and the temperature is going high, it's going to affect the battery. And most of the time, that is what causes most battery to swell up at the end of the day. But when the battery understands, oh, this battery temperature is high, let me even stop charging the battery until when it's cooled down. For example, you pick your normal phone. Let's say this is a phone and I'm charging it. When I plug it to a charger and I'm using it, I discover that it starts getting hot. When you observe very well, you discover that the charging doesn't increase anymore. That's what the BMS does to your battery. Because if you keep charging, the phone might explode because of the battery is hot, right? So the BMS inside this phone manages the charging parameters and the charging procedure of the battery, right? So that when the phone is hot, it doesn't change charge. If my battery was charging from 0% to, let's say, it gets to 30%, and the temperature of the phone is around, say, 40 degrees Celsius, this battery percentage will move above that. And I observed that severally until the temperature drops. When the temperature drops to what has been programmed inside of it as a safe temperature for it to continue charge, it will now start charging. You now see the battery percentage will now start increasing upward. So the same applies to your lithium ion batteries and inverter systems. And the only way that can work is if you have this connected in between your inverter and your battery. Very important. Because if you don't have this connected, at the end of the day, your battery, maybe we are in Nigeria, we are in a hot region, you place your battery outdoor, and probably you don't give it a good ventilation, you don't put an air conditioner in the storage unit, and this man keeps charging this battery. The temperature of the battery is high, but the inverter doesn't know because there's no communication between it and the BMS communication cable. So let's go ahead, let's discuss step by step what are the benefits of this cable and the disadvantage if you don't connect it between your inverter and your battery. Very important. So number one, when you don't connect, the benefits of this, okay, let's say the benefits is, number one is it helps you to have correct charging. So with this cable connected into your inverter and your battery, this is our communication cable, it helps your battery to charge properly. It helps you to charge properly. Without, now most of the time you see that on your inverter screen, the battery percentage is 50%. That is a state of charge, SOC. But on your battery screen, inverter, on your battery display, you see that it's showing 70%. That is a state of charge. So you can see that there's a problem here. When this guy is not reading the same information as this man, it means that there's no understanding between both of them. But with this, your RS485 communication cable or CAN, as the case may be, once it's connected in between both of them, you will discover that this guy will reset itself. Because this guy is showing 70%, it will reset itself to 70%. So one, correct charging information. It helps you to get your correct charging. But without this, it won't give you correct charging. Now, let's say your charging voltage is 57.8. That is a boost, or let's say the float charge. The float charge is 57.8. Without this cable, even if it's set, you might not get the best or the correct information for your charging for your battery. So without that, you might not get the correct information. Part of correct charging is your voltage and your current, right? Voltage and current. Now, most inverter, you set a charging voltage for it and you set a charging current for it. For example, your regular lead acid battery. When that voltage, when the inverter charges, your inverter discharges, say, to 40, let's say 48 volts or 49 volts, it means that it has been discharged. It needs to charge back, and it's the charging voltage should stop at, or the nominal voltage should say, let's say 51 volts. So when the inverter is charging your battery, the voltage keep climbing up from 48, 48.6, 49, 50. It keeps climbing up. So once it climbs up, it gets fully charged, it retains the voltage. The same applies to the current. The current keeps going also. You have 50 amps. Your 50 amps shouldn't be at 50 amps all through the charging stage. At a point, it should drop. If it doesn't drop, it means that the inverter and the battery are not communicating properly. So it means that this inverter is not getting the correct information from this battery, and the battery is not sending it to the inverter. And at the end of the day, your battery will keep having issue. So very important is this for correct charging. If it's not there, you will have your battery or your inverter sending incorrect information to the battery. Your battery might be shouting, I'm full already, but this chairman here, this inverter will not know. You just keep pushing power or energy into it. So one of it is correct charging and incorrect charging. Correct charging is what this does, but if you don't have it here, then you have incorrect charging. Then the next one is the discharging aspect. You have your incorrect discharging. Incorrect discharge. That's a disadvantage if you don't have your BMS communication cable. Let me call it BMS communication. If you don't have it between your battery and inverter, it has incorrect discharge. Most of the time, lithium battery could be discharged to, you can remove 90% of the energy stored inside of it and you are left with 10%, right? For your inverter, you did custom setting on without any communication between the BMS of the battery and the inverter. That inverter will discharge your battery to 0%. Yes, it will do that. But when you have a communication cable in between, most of the time, that's why you get to your site, you see that your battery is dead, like there's no charge inside of it. So as a result of, there's no communication between the inverter. When your load is connected, the load keeps discharging the battery, keeps discharging it. If there is a communication between the battery and the inverter would get an information from the battery through the BMS that, oh, the recommended depth of discharge for me is 90%. So now I reach that 90%, stop discharging. And what it does is it cut off the load from the inverter. So the inverter gets that message that, oh, I've reached 90%, I just have 10% left inside of me. Then cut off the load. So the inverter stops supplying power to the load. It stops supplying power to the load. That's a safety, right? Yes, it's a safety because it doesn't allow this man to go down to 0%, which I know they might affect the cells inside the battery. So it retains that 10% and stops supplying your load. But if it's all all these stand-alone inverters or inverters that don't have communication between the battery and the inverter, it will discharge the battery down to 0 because there was no command telling you that I've been discharged to my safe level, my recommended DOD, depth of discharge, stop discharging. So that's one of the benefit of having your BMS. It helps to regulate discharge. But if you don't have it, that is this communication cable, sorry. But if you don't have it, it discharges your battery to the bad level, right? So, and also you also know that you could set your level or depth of discharge by yourself in your battery. Most inverter will have the DOD, we have the DOD restart, then cut off, we have the shutdown. So you set, when do you want your inverter to cut off, right, or shut down the load? This shutdown percentage means sometimes you can set, say, 15%. If your battery say their depth of discharge is 90%, you could set 50%, so that when, okay, we have the low voltage. So when the battery is low, you give it, say, 15%, sorry, 20%. So you set 20% on it. I'm using the brand we deal on there as an example. It has the low cutoff, then you have the shutdown, you have the restart. So for example, when it reaches this low, the inverter starts giving an alarm. It's 20%, your load will still be powered from it. It starts giving you an alarm, a BP alarm that battery is low. But now we put a shutdown or a cutoff, meaning once the battery reaches 50%, cut off the load. So the load will be disconnected from the battery so that the battery can still have stored energy out of it. This restart means after, let's say, 25%, after there is a source of charging the battery, even when the battery starts getting charged, don't supply power to the load until the battery reaches 25%. Because of course you can't, if for example you are using just grid, you don't have a solar system, when your grid is not stable in the location you are in, when your battery is discharged to 15% and the load is cut off, once it detects grid, it begins to charge the battery. Of course, it's meant to bypass to power your load. But so if it now bypass and is powering your load and is charging your battery, it doesn't take from the battery when the grid goes off. So when the grid goes off, for example, and your battery is 20%, your load will be cut off. You will now be wondering, why is it that my battery is already above the 15% cut off, it's 20%, the inverter should start powering my load? It's because there's a command on it, restart at 25%. It means that when the battery has not gone into 25%, don't send power from the battery until it reaches that 25%. When it reaches it, and for example, the grid goes off, then your battery can still power your load. Then it can now drop also to 15%. It's a safety for your battery. And this cannot happen if you don't have this connected to your inverter and battery. So it's very important to have this connected between your inverter and battery. So this is number 2. Then number 3 is you have incorrect SOC, state of charge reading, between the inverter and the battery. I've explained that, or I've stated that before when we started this class. So between your inverter and battery, there's always the state of charge. And most battery display there, I'll say your battery is 70%. Your inverter is 70%. When you have the communication cable in between, this is your positive and negative power cable. So if you have this COM cable in between there, this information will be accurate. But in an inverter where you don't have this communication in between them, you will discover that your inverter is showing 50%, while your battery is showing 70%. That is an inaccurate reading. I should bring a concern to you. For a professional, when you go to a site and the information between your inverter, it could be otherwise. Your battery could be showing 100% and your inverter is showing 50%. You should draw your attention to something that there is an issue somewhere and you need to attend to it. So inaccurate state of charge. If you don't have a communication cable between your inverter and battery, you can experience that a lot on your site or on your project if you don't have that communication cable connected between them. Then let's go to the next one. The next one is BMS protection. Your BMS protection may cause sudden shutdown. If you don't have this connected between your inverter and battery, the BMS protection may cause sudden shutdown of your system. And why does it do this? It does that to protect your battery from damage. Because, for example, imagine your battery is being overcharged because you don't have a communication cable connected, inverter and your battery. You just have this positive, negative. You just have this connected and it's being overcharged, right? When you have your communication cable in between them, it helps to shut down the BMS and disconnect the load or the inverter from it. So without this communication cable between your inverter and your battery, the inverter would not know that so much bad current is being put from the battery, which of course there's no way the battery can tell the inverter because there is no communication in between them. So but when you have a BMS communication, this man would protect the inverter and cut off the BMS or cut off the supply to the load so that this battery is not damaged. As we also mentioned, when it comes to charging also, it helps to protect it. The information will be sent. A overcharge or overcharging is being sent to you, cut off. Over discharge is being sent to you, cut off. The temperature is more than what is recommended, cut off. So, but without this, the battery system and the inverter has no communication. And this guy will keep sending in dangerous voltage, over voltage, high charging currents, and that will at the end of the day affect your battery. So it's very important. The BMS protection may cause sudden shutdown because what is receiving is more than what is recommended. Also, your BMS also have an alarm. An alarm will be sent. So on this part of alarm, I'll give us practical example. If you have your inverter on your site and you have your lithium battery, this is your power cable, positive and negative, and this is your communication cable, COM cable. First, if this communication between the inverter, if you have selected lithium, because if you selected lithium, one, if there is no communication cable between the inverter and the inverter will give you an alarm. And likewise also the battery, it will give you an alarm because you didn't select any communication between them. Two, you didn't select a protocol or there is no communication cable between them. Then two, if you have selected the wrong protocol, it will also give you an alarm. So there is a protocol, there is what matches, that's why most inverter brands will say compatibility. Their battery or their inverter is not compatible with a particular brand. Like for example, Jeho has brands of battery they are compatible with. Meaning, once you buy a Jeho inverter, there are brands of batteries that it can communicate with using your communication cable. And also, Jeho battery has brands of inverters it can communicate with when you put a communication cable. Most of the times, I don't sell Jeho to people that will be using inverters. I mean Jeho batteries to people that will be using inverter that can't communicate with it. Because if I sell, it means that your warranty is void. Because the battery is going to fail as a result of no proper communication based on its parameter, its charging voltage, charging current, the depth of discharge recommended, the temperature it should be operating in, and other information that particular inverter you are connecting on it should pick from the battery to be able to manage the battery lifespan. So if I get a battery that can communicate with the brand that I have, right, it means that I'm just taking a risk. Because one thing might happen, a battery that has 5 years warranty, because there is no communication between the battery and the inverter, after 2 years, you will discover that the battery that lasts, for example, 5 hours every day, the backup hours drop on the same load. Or you discover that your battery begins to get swollen up, because that is the most things that happen when your battery gets overcharged. When your battery gets overcharged, the cells begin to swell up. You begin to see the battery begin to swell up. The normal shape it was before, it gets swollen because it's getting so much charge into it that is not being regulated. So the alarm comes up that there is no communication between your battery and your inverter. So that's why it's very important you have a communication cable between your inverter. When your lithium battery has a fault, the alarm comes up on the inverter also. Benefit of your communication cable. But if this battery has a fault, it's showing an error. Let's say F23, or maybe there's an error F29 is on its screen, but this man keeps on discharging the battery. But most of the time, the BMS in this battery will cut off supply on its own, and it will draw the attention of the installer or the owner that my inverter is not supplying power. Why? When you come closer, you see that the battery is giving an alarm, right? That is just the benefit of BMS. So it gives you an alarm that is sent to the inverter, and if you have a monitoring unit on your phone, if you have a remote monitoring on your phone, you could check on your phone and see the alert. Oh, there's an error, there's a problem on my battery side, I need to go and check it, right? So it's very important. Also, if you don't have these cables connected, or maybe the cables were connected before and something probably happened, it's pulled out. Sometimes maybe if it's an exposed place, someone might just go pull it out, or in process of trying to do maintenance, it's pulled out. When it's pulled out, your inverter will give you an alarm that the communication, you have selected lithium, but there's no communication in between. So you have to trace it also. There was a time I have a site. Another aspect again is your protective device. We call it MCCB DC between your inverter and your battery. Most of the time, these batteries, you don't put power on the breakers when the battery is on. Okay, you want to power on your inverter from scratch, right? What you do, you turn on your battery. When it comes up, you take up the breaker. When the battery breaker goes up, then you turn on your inverter. When you do that, for Jeho inverter and battery, the battery will start showing an error, F29. That is not the normal procedure for starting your battery or your inverter system. That is commissioning. So this battery will give you a warning that no, this is not the way I want you to start me. What you do is this: you power on this MCCB first. You on the MCCB, then you power on your battery. So when you do that, it's not receiving a surge or information that there's a on that just came on abruptly. So once you have powered this on, this is number 1, number 2, then your inverter is number 3. This is your MCCB, this is your inverter, and this is your battery. So if you follow this procedure, your system will come on properly. There won't be any issue. You on your battery breaker, MCCB, number 1. You on your battery switch, number 2. Then you power on your inverter. So with that, your system comes on properly. So advantage of having this is to recognize any fault alarm in between the inverter, battery, and any other aspect of it. Another thing that it helps you to do is to what? Helps increase the lifespan, or helps maintain the lifespan that has been designed by the manufacturer for this battery to last. If you don't have it, the lifespan is reduced. Reduced lifespan. If you don't have a communication cable between your inverter and your battery, the lifespan is reduced. And how will the lifespan reduce, you might be asking? First, from overcharging. Yes, when your battery will overcharge, we said the battery will get swollen up. It will reach the expected lifespan the manufacturer have designed it for. But if you have this, it helps protect it from being overcharged. Second is, let me write it, overcharging. Second is temperature. When your battery is in a hot temperature, or the temperature is high and is being charged, when there is no communication cable, the inverter would not know that the battery is hot and stops sending charge into the battery. But with this helps to send the information to the battery to the inverter of the battery temperature. So when the inverter detects, oh, this temperature, I shouldn't send a charge to the battery, it's cut off charging the battery, and that helps your battery to last longer. So overcharging, over discharging. When you keep over discharging your battery above its DOD, depth of discharge. When you over discharge it always, it's recommended to discharge just 90% out of your battery, and you keep discharging to 0, 0, 0, 0. It reduces the lifespan. But with this communication cable in between, even if you don't program your DOD, the inverter automatically detects the manufacturer DOD set on that battery. And when the battery gets to that depth of discharge, say for example 90%, once it's just 10% left, it disconnects the battery. Disconnect the load first, then your battery remains until there's a charge into it to raise up the battery. So the lifespan of your battery will be reduced when you don't have a communication cable connected to your battery. So if you are a home user, a C and I user of solar energy system, very important to ask your installer about the CAN RS485 communication cable between your systems. Are they properly installed and set for a communication between your battery and the inverter? Because you are mindful of the lifespan of your battery and the inverter. Then the next aspect is another thing you might observe, your inverter might refuse to operate. Actually, this is number 7. When you don't have a communication cable between your inverter and your battery, this is your battery positive and negative, the inverter might refuse to operate, because most inverter, and nowadays most inverter are excluding flooded AGM from their design. Like for example, the Jeho high voltage inverter, it doesn't have a section where you select flood or AGM, because it only works with lithium battery. So in the situation whereby you have installed the inverter and you don't have a communication cable between the battery and the inverter, this inverter will refuse to operate. Of course, it might come on, but it will not give out load because it's not communicating between the battery. So inverter might refuse to operate. or most of the time, when there's no communication cable between these two, most smart inverters would not come on at all. Yes, because they are expecting the communication. Most smart inverters will not come on because it's a protection for itself. Because if you just disconnected to this and you have programmed it for lithium battery, it's expecting a communication between the battery. There's always a BMS, and it has not detected the information from the BMS, because it is BMS that will send those programs, those information by the manufacturer from the battery to the inverter. So without it, it might not operate. So that's one of the disadvantage of not having a communication cable between your inverter and battery. Another thing again that this guy does is this. If I want to parallel, as we already said, your CAN RS485 communication cable is to enable communication between devices. If I have inverters, say I have 12 kVA, 12 kilowatts, 12 kilowatts, 12 kilowatts. I have 3. You could have several numbers depending on what it has been programmed to, the maximum number you can parallel. If I've connected the AC part of these inverters together and I don't connect my communication cables in between them, the inverter might not communicate to work as one. Yes, they will not communicate to work as one. You need your communication cable between the parallel ports. Inverter have A, B, A, B, A, B. These are parallel ports. So you connect to this, you connect to this. So once you have this communication cable connected, the 3 synchronize together and work as one. But without this, and you want the 3 to work as one, they won't work. The same applies to your battery also. You want to parallel your several batteries together. So you have out, in, out, in, out, in, out, in. We always know that from your out to your in, out to in, out to in. This one becomes your master that goes to your inverter. For you to parallel them, you want to have a larger battery bank. Say these are 10 kilowatt hour times 4, which will give you 40 kilowatt hour. For them to be able to communicate well with the inverter, you need this communication cable. So if you just install your inverter, you connected them in parallel, these guys are speaking to themselves, but you don't have a communication cable in between this, there's going to be a problem with your system over the years. At the point, you might see that one of your battery is being charged, this man is showing 70%, this is showing 65, this is showing 65, this is showing 70%. So there is no communication between them based on their state of charge and other information. Because most times, if this battery state of charge is low, this guy will want to charge it, will want to send charge to balance everything in between. And it can only happen using your communication cable. So without the communication cable properly plugged into the battery, also to the inverters, which helps them to communicate properly, then there will be an issue. Also, you also know that if it's not there, the inverter will keep showing an alarm or it keep giving an error signal. There will be a fault signal continuously, because it's a protection over your system for the longevity of your system and also for its performance. So the presence of a communication cable, CAN RS485 communication cable in your solar system, that is the inverter and battery, is very important. Also, for those of us that uses MPPT to charge our lithium battery, and we don't have a communication cable in between both of them, we are doing our customer a disservice, right? Because this MPPT will keep sending wrong charging information to your lithium battery, and over the years this battery will get damaged, right? So when you are if you are on a site that has an existing inverter and the inverter can't charge your lithium battery properly, and you intend to get an MPPT, please get a MPPT that can communicate with the battery. There are MPPT brands that I know that can communicate with your battery. so that you have this communication cable. Apart from the power, DC power cable, you have the communication cable between the MPPT and the lithium battery. With that, you know that you have done an excellent installation. You have peace of mind. Your customer will refer you more because you have installed a system that has a proper communication, and the charging is being regulated, overcharging is being regulated, the temperature is being monitored, every other information is being picked from it. The depth of discharge also is being monitored also. So please, in this era we are in, a lot of charge controllers in the market, people are going to lithium batteries. Do it proper to get a communication cable between the MPPT you are using on your site with your battery. And most inverters, you could connect your MPPT through the inverter. So for example, you might be asking, if I have my inverter on site and I have a MPPT, how am I going to, and this battery has just one communication port that goes to one of the devices. This is your inverter and this is your MPPT. How do we make both the inverter and the MPPT communicate with this battery? This is your lithium battery. So all you can do is this inverter, of course, when you are getting MPPT like this, you should get an inverter that matches it, or the same brand, so that what happens is you can just take this communication cable from this inverter to this MPPT. Then from the MPPT, it comes to the battery. So with this, there is a communication loop between the three of them. 1, 2, 3 is communicating. And what happens here is this. If, for example, this inverter has only grid, that is NEPA supply in Nigeria, and it has your solar, it can also help to manage the customer's power consumption when it comes to grid. In the sense that when you are in the daytime and there's a lot of sun power to harvest to be able to charge your battery, and there is grid also, this inverter will not keep powering your load from grid and charging the battery when you have your panels. What it does is this: it will, because of this communication, it will monitor that there's a lot of power from the panel. It pulls that power from the charge controller, or it allows the charge controller to charge your battery and also gives power to your load. So your grid is being maintained, like there's no usage from your grid. 0 watt is being consumed. So it only comes to use the grid when it detects that your battery power has been discharged to maybe 20% and there is no sun. So it now starts taking power from the grid to charge your battery and also power the load. So very important, when you have a site that needs an external MPPT, ensure there is a communication between the three of them to be able to safeguard the life of this battery. And we also know, for example, you might install an inverter on the site. Most of the time, what I do is this: if I have an inverter and the solar power from the inverter is based on the inverter capacity is not sufficient to power my customer's load and also charge the battery bank I have, what I'll do is this: instead of me getting an MPPT, I will just get a second inverter. Say I have a 6 kilowatt inverter and this is not sufficient for my solar power, right? And the other option I have is to get an MPPT. If I have an MPPT that can't communicate with this inverter, I'll just get another 6 kilowatt inverter. So it means that we are going to connect this in parallel, and this goes here to charge your battery. So you have your bus bar is where your battery power cable comes to. So you have your bus bar. So it's very important. This session is a very big one that we can't cover in a sitting, right? So we'll be stopping here. If you have any question, post it on our comment section or contact us directly. We'll give you clarity on this system. So let's go back to what we have just covered. One, it helps you to parallel your system. So you can, with your communication cable, the parallel function can be activated, meaning You can parallel this communication can help you parallel your batteries, your inverters, lithium, so your MPPT. It helps you to power without any issue at all. Importance. Now, it helps your inverter to operate at every point in time. Doesn't keep on bringing up an alarm or an issue because you have a communication between them. The next is it helps your battery lifespan to be maintained. Yes, most battery has 6,000 cycle, some 8,000 cycle. So with a communication cable between the inverter and the battery, it helps that lifespan to be retained. But without it, the lifespan is reduced. It helps an alarm or a notice to be sent to the inverter if there's an issue with the battery. Yes, an alarm props up. But if you don't have a communication cable, the inverter will keep working and might end up damaging your battery. The next one is the protection. It helps protect this man. BMS protection is activated, which might cause sudden shutdown and whatever. If you don't have it, it's because it's sudden shutdown. But when you have it, the protection is activated, is kept, and you don't have a misbehavior on your site. Your incorrect state of charge, I have explained. With this, you have a correct reading in between your battery and your inverter. And incorrect discharge, the same thing also. It doesn't over discharge your battery and stuff. So correct charging with your communication cable, it helps you to charge it with a proper charging voltage, helps to maintain the charging power, the current, and every other thing that relates to charging. But without your communication cable, there's a wrong or improper, incorrect charging. So that's just it basically for this class on RS485 CAN communication cable. Communication between devices. Very important, always use it. Now you might say, oh, most brands, we can't get the cable that will communicate with my battery. Most of the time, this is a RJ45 pin, this is a pin, and this is your Cat6 cable, right? So some of them we call the standard, which is white, orange, orange, white. Okay, you have your white, orange, orange, white, green, blue, white, green, blue, white, blue, green, white, brown, brown, white, orange. So we have this standard 4 pairs, 8 conductors, white, orange, orange, white, green, white, orange, orange, white, green, blue, white, blue, green, white, brown, brown, right? So we call it, this one is called the standard communication cable, meaning this standard is followed. There is no interpolation or let's say manipulation on it. So this is the standard used to communicate between the device. But in most inverters, which I have done, for example, let me give you an example. I can help your Jeho inverter to communicate with your Felicity battery. For those that love this brand, Felicity, right? But with this standard communication cable would not provide that solution. You have to cream this cable. You are going to cut off some pairs out of it. They probably use just a pair of this cable on both sides. So there's how it's done. And it's from the RS485 protocols. Like there's a list of tables your manufacturer gives you that helps you to know the communication. The same also applies to other battery brands, which I won't mention it. You don't use a standard. If you use it, it won't work. But there's where you crimp it, then you go, there's a protocol you select that it works with it. So with that, you have peace of mind that your battery is communicating. Because if you have, for example, this brand and this on site, most times you go to the site, you discover that the Jeho is showing 50% and the battery is showing 30%. Because the communication is not established yet. So do yourself well to understand how this works and use it always in your solar energy system installation. Thank you and have a nice day.